Right, hello everyone, welcome back to a brand new video. So in today's video, what we're going to be looking at is getaddrinfo. Okay, so it's one of the system calls that are heavily used in network programming. Just to give you a bit of an update on the series, where we're at. Effectively, we are looking at network programming. Recently, we just finished the Alexa series and it was very fun to work on a project. So with that in mind, I decided that what would be nice is to effectively create a series on network programming, something I'm not familiar with. This whole channel is about learning C from start to finish, and I feel like projects are the best way to do that. Trying to stay away from AI as much as possible, only using it for learning purposes only, because I think that's the only way in which you learn. So we're using Beej's Guide to Network Programming. It's a solid resource. There's a wealth of knowledge in here. For those of you who watched the earlier episodes, you'll know that we've learned quite a bit already. We created a program already, and in this episode we're going to create another program, but it's just simply going to be using getaddrinfo. We're not going to be using any of the other system calls. So without further ado, let's get started. Okay. To begin with, what is a system call? It's effectively it's not much different to a typical procedure or typical function that you'll see in a programming language. The only difference is it interacts with the operating system. Okay, so it's doing something low level. It has a trap instruction inside there. Again, for those of you who have watched my previous videos on book recommendations, you would have seen that I recommended a book by, I forget the author's name actually, because I believe it's like a French or Canadian pronunciation on there. But effectively, it's called Operating Systems 3 Easy Pieces. It breaks down operating systems in terms of virtualization, which I think is where they cover system calls. Yeah, that's correct, because the next chapter is concurrency. And then the third chapter then is persistence, which is all about how data is stored on secondary storage devices. So it's very interesting. Read that book. You'll get a general idea of everything on there. But without further ado, let's get started. Okay, so this is the section where we get into the system calls and other library calls that allow you to access the network functionality of a Unix box or any other box that supports a sockets API for that matter. So it's BSD, Windows, Linux, wherever. Okay. When you call one of these functions, the kernel takes over and does all the work for you automatically. The place most people get stuck around here is in what order to call things. Okay, so you can use the man pages, but as you probably discovered, they're not great for this sort of usage. So of course, the man pages, for those of you again, read OSTUP, all the information is in that book. But for those of you who don't know what the man pages are, it's the manual pages. They effectively, if you go in the terminal and type in man space man, you'll see an introduction into what the man pages are. They're effectively in your terminal. They give you an idea of all these different system calls, especially with regards to C, because the C standard library comes shipped with Linux and with Mac OS. So if you use the manual pages, you'll find a lot of information there about the sockets API and so on. Okay, but the order in which you're going to use them is very tricky. So as they've given us a few sample code bits and bobs there. Okay, and they say that we'll be passing data around the internet like the son of John Postel. John Postel, I believe, is a computer scientist. Don't know too much about his contributions, as with what I mentioned earlier, I think, in the series of some sort of computer scientist I had no clue of. So my apologies for that, but of course, they've left a great legacy because they've, well, I'm assuming he's done something or made some tremendous contributions to the web. So fantastic, but I'm not going to get bogged down in that, okay, for now. Right, please note the brevity, many code snippets. Okay, we're not going to read that, that's fine. Right, so getaddrinfo. This is all we're going to focus on in this episode. I do apologize, it's going to be a shorter one, but nonetheless, hopefully we'll learn something from it. Okay, so it's the real workhorse function, but the usage is actually pretty simple. So it helps set up the structs that we'll need later on. Tiny bit of history then. It used to be that we'd call a function called getHostByName to do DNS lookups, and then you'd load the information by hand into the struct, sock addressing. This is no longer necessary, thankfully, nor is it desirable if you want to write code that works for both IPv4 and for version 6. So in these modern times, you now have the function getaddrinfo that does all kinds of good stuff for you, including DNS and server name lookups, and fills out the structs you need. So that's fantastic. So we don't have to do, it's quite funny actually, because like I'm viewing this as low level, and it is low level of course for me, because I've not done much with C before. I mean, this is the first year I've ever programmed in C. So, you know, for me, it's a bit unusual, but it's actually like a lot of people have done a lot of work and taken a lot of things kind of like off our hands, if that makes sense. So it's like not as low level as it needs to be. So that's fantastic. You know, you can't complain learning C. I mean, it is low level, but there's even lower than that, I suppose. So these system calls are very useful, as you can imagine. Right, we'll move on. So this is effectively, these are some of the functions we're going to use now. I may as well add them in actually, because it'll probably save a little bit of time while we're going to be creating our example program. So we're going to need stdio.h. Oops. We're going to need, include std, string.h, I think we're going to need. And I'll add these three in then. Okay, so include std sys types.h. And we're also going to, what am I doing? If you couldn't tell, I'm still getting used to this Glove 80 keyboard. It's been too long. I should be a whiz on it now, but I'm not. Right, socket.h, so that's fine. Right, okay. And we're probably going to do this later as well, so let's just get that done. Int argc and char arg. Fantastic. Okay, right, cool. Oh, and I didn't include one more, so let's do that. Include netdb.h. Great. Right, okay. So getaddrinfo then. What is it? It's a system call. What is a system call? A low-level operating system instruction, okay, that's going to do some low-level stuff for us. Fantastic. Okay. It's going to return an integer, and it's effectively called getaddrinfo. It's going to take in a node, which is going to be a IP address or the name of a host name. So effectively, like, you know, if we want to call google.com, for example, we could just put www.google.com in there. Okay, one IP address if we want to. We're going to specify the protocol used or the port, the service that's been used, sorry. So it's either HTTP or port number. Fantastic. It's also going to take in hints, and we're going to explain shortly what hints are, and effectively a pointer to the results as well. Okay, so you give this function 3 input parameters, and it gives you a pointer to a linked list. So that's the results. The node parameter is the host name to connect to, or an IP address. Next is the parameter service, which can be a port number like 80 or HTTP or FTP, Telnet, whatever. Okay. Finally, the hints then, which is already, we would have already filled out with relevant information, and that looks something like this. Okay. So we have an integer, which is going to be a status. Okay. We have a struct of type address info, which is going to be our hint. So these are effectively, we're passing through like the parameters that we want effectively. Okay. So for example, what we're going to pass through is AF unspecified, which is going to be effectively, we don't care if it's IPv4 or IPv6, we don't care. We're also going to pass through the socket type, which is going to be TCP in this case. Okay. And we're also going to pass through AI passive, which in all honesty, I don't know what the alternative is there. It fills in the IP for us. I don't know what implications that has, in all honesty with you, and I don't think I'm going to research or look into that until I have to. So for now, that's fine. So that's effectively a bit of breakdown. We also free then as well. So let's read this then. Okay, so notice that I set AI family to unspecified, effectively saying that I don't care if it's IPv4 or IPv6, so that makes sense. Again, we can use AF inet or inet6 if we want to specify what it is. That's fine. Okay. We also have the AI passive flag. This tells getaddrinfo to assign the address on my local host to the socket structures. This is nice because you don't have to hard code it. Okay, so I guess it's just there. It just fills in the blanks for us effectively. Okay, of what the IP address is. That's my guess. Then we make a call. This is effectively an error call. I think we'll just to check if there's an error occurred. So status is going to hold. If it's not equal to 0. Then we're going to run that as an error. So it needs to be status. If it's successful, it'll return 0. So if it's successful, it won't execute this bit of code effectively. Okay. So that makes sense. And then finally, then when we're eventually all done with the linked list, the getaddrinfo so graciously allocated for us, we can and we should free it. Okay, so free address info is there then as a system call to effectively free that data structure that we have created. Okay, so here's a simple, if you don't know what linked lists are, by the way, again, Grok and Algorithms is a fantastic book to get you familiar with your data structures. So I'd recommend that. Okay, in all honesty, I didn't read the book all the way through, but the pages that I did read, or the chapters that I did read, sorry, kind of give you a good breakdown of the basics, the low-level stuff that you need to be familiar with. Okay, it goes into things like big O notation, which is something I never touched before looking at that book. It also goes into like data structures such as hash tables, which we take so for granted all the time. So that's interesting. Anyway, so here's a sample. If you're a client who wants to connect to a particular server, say www.example.net on port 3490, again, it doesn't actually connect, but it sets up the data structures that we can use later. Okay, so again, it's not doing anything, but this is effectively what we would run to set up a client who's going to connect to a server on a particular port. Okay, so that's that. Right, this is what we're going to do. Okay, so have I missed out any? I think I have missed out some libraries. Got NetDB. Okay, we need NetInet. I've used this one before, I don't think. So let's add that. NetInet. And then in.h. Oops. There we are. Right. Right, okay, so let's get started then. So I gotta make sure my big head's not in the way of the code as well, so apologies if it does get the case. I promise I will scroll down if I remember. Right, okay, let's go up one. If I click on the thing and delete that. Okay, right, so the first thing we need to do then is set up our struct. So that's going to be address info of type address info, sorry, and we're going to create hints. We're going to create a pointer to our results, and we're also going to create another pointer, which I think is just going to be a pointer that we're going to use to walk through our list, okay, of results. So that's effectively all we're doing there. Now what we're going to do is run a check for argc. Okay, so we're going to do list if argc is not equal to 2, then what we're going to do is we're going to do fprint. So we're going to print an error here. Call standard error, and then we're going to do usage show IP hostname. So effectively saying that, look, if we get, you know, what we're expecting here is 2 arguments, and if we don't get that, then we're going to return an error. Okay, so that's effectively all we're doing there. So fantastic, that makes sense. Right, memset is interesting. So for those of you who watched the Lexa project that we worked on, okay, I would highly recommend it because it kind of ties into this, what we're doing here. But effectively, okay, all we are doing, I don't know why it's not showing that. I think it's actually because I'm in dark mode. There's a left parenthesis there, so just be aware of that, okay? If you've got dark mode enabled on Mac. So memset, effectively all that's doing is it's setting up the structure, it's filling the values with, it's effectively ensuring that the struct hints is empty. Okay, that's effectively all it's doing, setting all the values to 0. So what we're going to do then is set up our hints, which is going to be AI family. We're going to say AF unspecified, so that is, we don't care if it's IP version 6 or version 4. Okay. So we've done that, and then we're also going to do hints.ai. By the way, AI doesn't stand for artificial intelligence, it stands for address info, if you were wondering. Sock stream. Okay, great, so we're saying I want effectively TCP sockets. Right, okay. If, and we're going to say status. Okay, so this is, again, we're checking here now to make sure that we're getting, that it's going to return a success. If status is equal to get address info, and we're going to say arg v1. So effectively we're passing through whatever we pass through when we execute the program, that is going to get passed through get address info. We're going to set the next value, which I forget what that is actually, to null. And then we're going to use our hints then as our parameters, or all the things that we configured. And then we're going to effectively point to our results then, data structure, which we had previously set. and then we're going to do not equal to 0, and then we're going to have a little bit of code here, which is effectively going to say, which is what we see in the previous one, get address info error. Okay, so we'll say fprint std error, and then we'll say get address info. We can have anything there. Okay, we can shorten that. Oops. And then get address info underscore, and then we'll say status. Fantastic, and then we'll return 2 then, because that's our second error. Great. Okay, so we're in a good place for you now. Hopefully this is all going to go smoothly, and we're going to have no errors. I say unconfidently. Right, IP addresses for S, and then let's have that. I don't know what we're doing here. So, right, okay, yeah, we're just saying, right, okay, these are going to be the results for this particular IP address that we're trying to reach. Okay, hopefully you can see this. I'm trying to remember to scroll down. My camera's just too big. Right, fantastic. Right, where are we? We are here. Okay, right, so what is this doing? This bit of code then, I assume, it's going to loop through our results until we reach a null, which is effectively the last, until we reach, like, we have no more nodes left to walk through in our results. And then, so let's do this. So P equals results. P is not equal to null. We're going to say P equals P AI next. Right, okay. So we're saying that the pointer then is going to equal the next. So it's effectively, that's a good way of walking through our linked list, which is something I haven't seen before, actually. I think every time I've set it to, I'm not sure I've done that before. I've never used the for loop to walk through. It's normally a while loop, but anyway, don't know why that's surprising to me. But anyway, right. Now what we're going to do is, right, we're going to set up a few variables here. So we're going to say void pointer address char IP version struct sock address in, and we're going to struct sock address in 6, and we didn't give that a name, so IP version IPv4, oops, and then we're going to have IP version 6. Right, okay, so get the pointer to the address itself, different fields in IP version 4 and version 6. Okay, right, so if P AI family is equal to AF inet, so this is if it's IP version 4, then we're going to set IP version 4 to equal struct sock address in, so this is typecasting, P AI address, and IP version, address is going to equal IP version 4. Okay, I'm getting a little bit confused myself here. So again, there's just so much to keep up with. Right, IP version 4, and then right, we'll just have our else then. Okay, we'll look at this after and try to make sense of it. We won't worry too much now. IP version 6 equals struct P AI underscore address. Great. Okay. Address equals ampersand, IPv6 sin 6 address. IP version then is going to equal IP version 6. I think this is just where we're going to, this isn't allowing us then to print out. It's setting up the variables based on whatever the loop is going to say. So does it have inet? Oops, inet, n, right, okay, I know what this is doing. Network to presentation, so it's effectively printed out in a way in which we can understand. AI underscore family, address, IP string, size of IP string, printf, right, okay. So IP version and then the IP string then. We're also going to print out. Oops. Free address info. And I bet we're going to get a lot of errors. I'll be extremely proud if we don't. Okay, why is that? Don't know setup of error. IP version, IP string. Was that not set up somewhere? IP string, yeah, was set up, wasn't it? Or did I not set that up? Ah, I didn't. Right, okay. Right, okay. I didn't know that we could use this, actually, now that I'm looking at it, for both versions. So what I mean is, it's inet 6 address. Okay, any more errors? Oops. Wait, hang on. inet underscore n2p. Have I missed out? So I got net, inet, right, okay. Missing out ARP. Oops, include ARP a inet.h. And we got a spelling error over here. Fantastic. Okay, I think we got no errors now. Right, okay, so I'm gonna, if we think through this then a little bit, because of course we need to make sure we understand what we're doing here. Otherwise there's quite literally no point. So we have a for loop where we're saying the IP addresses are, and then we're effectively going to print out all the IP addresses. Right? So this is walking through effectively all of the results of the IP addresses that we're getting. This is going to be IP version 4, this is going to be IP version 6. If it's IP version 4, we're going to set IP version 4 is going to equal the AI address. The address is going to be, we're effectively saying that it's IP version 4. I think this is just completely setting everything up to IP version 4. And we're calling on this later when we print it out. So we're saying IP version 4 and then whatever the string is. Don't know whether we're setting it as the string. Oh yeah, it's in the for loop, just doing it for, right, okay. Right, but yeah, okay. So I think this is just saying, right, this is the type, if it's IP version 4, version 6, this is the address we're dealing with, and this is where we're going to store it. It's going to be a size of that. Okay, I guess that makes sense. I think, if I'm wrong, please let me know. Right, let's clear this. Right, clang, we want to do get ip.c, and then we're going to effectively, we'll just call it get ip. And if we run this now, get ip, and we say Google or www.example.com. Fantastic. Okay, so it's printing out what the IP version 6 addresses are and the IP version 4 addresses are. Now I'm really curious as to why it's printing out 2 options of each. So I'm going to look that up right now actually, because I'm just curious. Right, okay, so just from a simple lookup then, the reason why this is giving me 2 IP addresses. Okay, so first of all, let's talk about what this program's doing. Okay, now I'm sure it's going to go into it a little bit, but here, in fact, let's read this first. So as you can see, the code getaddrinfo on whatever, you pass it on in the command line. It fills out the linked list pointed by results, and then we can iterate over this list and print stuff or do whatever. So there's a little bit of ugliness there, where we have to dig into the different types of struct, sock addresses, depending on the IP version. Sorry about that. I'm not sure there's a better way around it. But they give a sample run, they show their examples, okay? So I ran the exact same thing, of course, and I got two IP version 6 addresses and two IP version 4 addresses. Now, this is effectively the IP address of this server that I'm trying to contact, okay, or this hostname that I'm trying to contact in both IP version 4 and IP version 6. Now, the reason why I'm getting a few different options is quite literally because there may be two different servers running for this particular hostname. So it's quite interesting, okay? It is quite interesting. And I guess it's a nice little place to start off with for network programming. So I don't think there's any purpose in me going deeper into this chapter for now, just because that was the only program that we had to run, and I'm conscious that time's gone on. So what I'm going to do in the next episode is we're going to look over each of these system calls, from socket, bind, send, receive, connect, all of that stuff, okay? We're going to go through all of this, and hopefully then, by the time we finish this guide, by the time we've gone through it, we can create our own maybe little web application where we have two different sockets open, people, and two different things talking to each other, people talking to each other. So that'd be quite interesting, okay? If you've got any questions, if you've got any insights, if you're experienced and you want to share something interesting that I probably glazed over in this episode, then please comment. Make sure you like, subscribe, because this channel is slowly growing now, but we've got a good community of people who are working on projects themselves, and I would love to share this with more and more people. So thank you for watching. I look forward to seeing you in the next video, and bye.